All right, so applications of percent. So now the quantities that we're looking at are going to be defined, and it's up to us to be able to distinguish what the percent is actually defining, what ratio the percent is defining. So again, we're going to be setting up and using a percent proportion to solve. Um, Once we translate the problem to a percent proportion, then we can just use our algebra to solve it. So let's look at this first one. And it says if the total mileage of the Appalachian Trail is 2,174 miles, use the circle graph to determine the number of miles in the state of Virginia. And if you look over at the circle graph, we notice that the circle graph is representing the Appalachian Trail mileage by state percent. So this portion of Virginia is 25% of the Appalachian Trail. So when we set up our proportion, we're looking for the number of miles in the state of Virginia. So this would be the actual miles in Virginia. And the percent of the percent that's given is 25. So that's going to be equal to 25 over 100. And we're comparing the state miles to the total Appalachian Trail. So the base in this case would be 2,174. So the number of miles of Virginia is 25% of the total miles. So to solve this, we just have to multiply both sides by 2174. Oops, sorry. So the number of miles in Virginia would equal, well, 25 over 100 is 0.25. And then if I multiply that by 2174, I'm going to get, on my calculator, 543, or excuse me, 543 and a half miles. Okay, so again, if we do this now that we have the idea that the percent represents the miles, and determine the number of miles in West Virginia. So if you notice, West Virginia is very small. It only has 0.2%. So West Virginia, compared to the whole length, 2174, is going to be 0.2%, 0.2 over 100. So to solve this, again, we'll just multiply both sides by 2174. So on the left side it'll cancel, and then 2174 here. So I get West Virginia would equal, well, 0.2 divided by 100 would be 0.002. So moving the decimal place to the left twice. And then if I multiply that by 2174, I get, on my calculator, I get, whoops, excuse me, 4.35. So it's such a small percent, only 4.35 miles of the trail go through West Virginia. All right, let's try another example. And again, we just want to determine the ratio that the percent, what we're looking for, the ratio that is defined by it. So if we look at these two problems, in 2010 to 2020, it's projected that the number of employed nurses will grow by 710,000. So it'll grow that much. If the number of nurses employed in 2010 was 2,740,000, find the percent increase. So percent increase in nurses employed from 2010 to 2020, round to the nearest percent. So the percent increase, oops, sorry, is going to be a ratio. So here I want the percent increase, And that's going to be then the actual increase compared to the starting amount or the original amount. So the actual increase divided by the actual amount, or by the original amount. So we're actually going to cover more of these types of problems later. But for this problem, then, we can set up our proportion. The actual increase was 7,000, or 710,000, sorry. And then that's going to be over the original amount, which is 2,740,000. And that's going to be equal to the percent over 100. All right, so to figure this out, I'm just going to take 71 or 710,000 divided by 2,940,000, and I get on my calculator 0.259124 ... There's a bunch more, and that's supposed to be equal to then P over 100. So if I want to solve for P, I need to multiply by 100, which basically changes this decimal to a percent. So it says round to the nearest percent. So I know multiplying by 100 will just move my decimal place twice here. So I need to round to the nearest percent. So looking at the 9, I'm going to round that 5 up to a 6. So this looks like approximately 26% would equal P. So that would be a 26% increase. All right, let's look at the next problem. Again, we're just trying to determine what's being compared in the ratio. Some problems are laid out pretty nice. It says the freshman class of 864 students is 32% of all students at Euclid. So this is actually pretty nice because the freshman class, or this 864 students, is 32%. So if I set up my proportion, I know that 864 is supposed to equal the 32%. So all I need to determine then is of all students at Euclid University. So how many students go to Euclid University? Well, I'm looking for then the base B here. So the freshman students out of the total students would give me 32 over 100. So to solve this, you notice our variable is in the denominator. So I'm just going to flip this. I'm going to use reciprocals. So I get B over 864 equaling 100 over 32. So just taking the reciprocal of each side, and then now to solve for B, I just have to multiply both sides by 864. So I'm going to get B equaling, and if you take and put this in the calculator, you get 2,700. So that represents the students at Euclid University, so there's 2,700 total students, right, at Euclid University.